No.
Spider-Man.
You like Spider-Man?
Yeah.
Ah. Spider-Man's okay.
And
Flash? Yeah, yeah.
In the one when we play Batman. Robin.
No, Batman's sidekick, yeah, Robin, yeah. The boy,
Yeah.
yeah. You saw the 1960s version of Batman?
Yeah.
Yes.
Yeah, I've watched all the movies.
Yes. The actor passed away, I think, last week.
Yeah,
Adam
yeah.
West, yeah. It's like, the original Batman. I downloaded the 3 seasons to watch again, and I thought they were funny.
The Penguin guy.
Yeah.
That was so bad. Like, if you watch it now, it is so bad.
But that's why it's good.
Yeah.
That's why it's good. Like, wow, this is so cheesy and so brilliant. Hey, come on. BFF?
Yeah, yeah.
Come on, traffic jam. Get moving. Watch the coffee. Oh goodness no, I'm not ready for that. That requires more psychological preparation.
I think we might.
Will I? Where did we stop last time in this one? Where did we stop? What was the last thing you wrote down? What was the last thing we did? The DC motor?
Yes.
Okay, so next now we'll do the Marvel motor. No? Anybody? Alright.
Would you take the Marvel motor?
No, too early
Yeah,
for
DC
jokes. No,
motor.
forget it. Right. Okay. Are you teaching her the Greek letter tau?
That was a bit of a joke.
I was, yeah. I said next after the DC motor we'll do the Marvel motor. And then I got just tumbleweed. Okay, so next now. Recall that
talking about Capcom a minute ago.
recall that the flux over some region of space is the number of field lines over that region. However, imagine now that the field passes through n identical regions we're interested in. Let us find a formula for the total flux. Well, kind of straightforward. So, for example, here's an area. Here's the same area. So let's say we have n of these. ... So here, for example, are 3 lines. So what is the flux here? It will be 3 Webers, for example. The total flux will be n the flux for one of them, because they're all the same, if it passes through all of them. And remember, we have the formula that flux density is flux over area. So flux is BA. So we can change this into NBA, like the basketball people. This total, we have a special word for it. We call it linkage. Now, I should tell you, there is actually a small difference, but for IFY purposes, we can think of them as the same. So, if I say what is the linkage, it means what is the total. And that is N multiplied BA. And I was using this formula here from yesterday. So this is the new formula for the start of this class.
So what's this formula used to calculate?
The total flux. What?
I mix up my physics and mathematics.
That's okay. It's just call them the Stephen notebook, and then it's all cool. Okay, you got that formula? Continue? Yeah. So we end up with this formula here, which you just wrote down. Now, if the field makes an angle theta with the normal of the region of space, so let's have a look at that. So, here is the field, and here is the normal, and here is the area, the space, and we're saying that it makes an angle here of theta. So when you look at the field lines, you need to resolve them into this direction and into this direction. If that's theta, then this one here is theta, which means this one here is the flux cos theta, and this one is the flux sine theta. Which one do I care about? Yeah, the one that's perpendicular.
Well, it doesn't form the right angle.
Which one doesn't now? The
The
cos and the sine? What do you mean?
Isn't that the resultant?
Which one? No. It looks a bit weird, but I'll show it here for you. This is like the resultant here. Sorry.
Oh.
Yeah. Is that clearer? And this is the cos and this is the sine then. So it's actually just the cos we care about because it's perpendicular. So if there is an angle of theta, then the formula just gets a cos theta. That's all that has changed. And finally, the total flux is also called the flux linkage, which I mentioned mostly. It's not exactly the same. Yeah. It's kind of awkward not to write when your teacher's beside you.
What's A?
What do you think it is?
I'm asking.
What do you think it is?
I'm testing you.
What do you think it is?
No, that's what
I
I'm
am testing you.
I'm asking, I don't know.
What do you think it is?
Oh.
It's not angle.
Oh,
It's not appetite.
Oh.
No. So what do you think it is?
Don't know.
It's area.
Wow. And B is the field.
Ball.
Oh.
It's B from yesterday's class.
Yeah.
It's flux density. Okay, did you write that down?
What's the N for?
Rails?
Number of.
Like the number of what? Lines.
Number of areas. Number of slices.
So what can I say?
Oh, yeah, number of regions of space. In the picture here, look, yeah, here. In this picture, N is 3 because there's 3 regions of spaces, 3 areas that the
So
field lines are passing
the
through.
question would be like 3 field lines or 3 regions.
Yeah, they'd say how many regions. Continue, you have that? Yes? Right, here's our first question now. A copper wire carries 2 amps of current. The current runs through a magnetic field so that the copper is perpendicular to the field. And the copper is 20 centimeters long and the field has a flux density of 3 Tesla. So what's happening here is we have your copper wire and there's 3 amps in it and there's a field perpendicular and the field it has a density of 3 Tesla and the wire is 20 centimeters long. And what else do we have? That's everything. Okay. So, I want you to look at your formulas and tell me which formula do I need for the first one to get the force.
Billy Jean.
Billy G. Give me all the letters.
BIL.
Yeah.
What's the rate on?
What's the what?
I was gonna ask what the rate is.
So the force equals BIL. Okay, I just want you to calculate that for me. There's the information again. You all got 1.2 newtons?
Yep.
Great. Now what formula do you need for the second part?
Why 1.2?
Is it not?
2 times
3
0.2.
times 2 times 0.2, which is 6 times 0.2, which is 1.2. What did you do wrong?
I don't know.
Well, tell me, I want to know what's
I know
wrong.
it's right.
Okay.
Wrong.
Okay. B part, if the angle is 80, so what formula do you need now?
Does it sine theta?
Yeah, double check, is it sine or cos in the formula?
Sine.
Sine. So, multiply the answer by sine 80.
What is the value of sine theta?
Oh.
1.18.
Okay. Okay, yep. Where's Yusuf today? And Wong? Any special reason? Something due today? What time?
11.
Oh, that's loads of time to do it. Do you have class at 10?
Well, you can finish it in the 20 minutes with the classes.
I don't know how big for homework is it?
Three questions.
3 questions,
3 slides.
3 slides, 3 questions. 10 minutes?
No, not 3 questions.
Three
It's like
slides.
1 slide, some question inside.
Ah.
3
3 bars.
slides per.
Let me put it this
3
way.
questions per slide.
How much time?
20 minutes.
1 hour?
15 minutes. 15, 20.
How much time to get it right?
How much what?
Time to do it and get it right.
Yeah, 15, 20.
Okay, good stuff. Okay, next now. A DC motor is used to turn a wheel. A current of 3 amps runs through the DC motor. The The magnet has a flux density of 5 Tesla. The wire runs 1,000 times around the square of length 20 centimeters. The side of the square is attached to a wheel. What is the torque? So which formula is this?
I-band.
Okay, calculate please. May I? Turning force. No turning force? Can I write? Force multiplied distance is turning force. Torque. The unit is Newton meter. Let me calculate.
You got it.
What did you get, Yahya?
3,000.
Yeah. I times B times A times N. No, I'm not getting 3,000 here.
Wait, no, it's 20 centimeters.
Yes, I see that. I'm getting 600.
0.2 is 5.
What's I?
I is 3.
Good. What's B?
5.
What's A?
0.2
No.
square.
Yes.
Yeah.
What's N?
Yeah.
1,000.
The answer is?
That's what we said.
Is it?
Yeah.
Oh, did you hear a different number? Oh, sorry. Right, so the torque is I-band, which comes in at 600 Newton meters. Yeah. Easy peasy? Well, not quite easy peasy. Next. A coil is wrapped around an iron rod of radius 5 centimeters, a total of 100 times from bottom to top. So if you look at me, please, you have a piece of iron and you wrap around it a coil 100 times. And then you have a magnet that runs from the top to the bottom. And the magnet has a density of 2 Tesla. What is the flux linkage? So what formula is it here?
NBA.
NBA. You know the N?
Yeah.
Yes. And you know the B? Yes. And you know the A?
Yeah.
What's the A here?
Yeah.
Yes. Okay, good. Calculate the first part, please.
Wait, the A is 0.05 squared. No.
Clearly.
By
R. But this is not the radius. Never mind. 2 pi R.
No.
pi square. Pi times 5 times 0.05 square.
Is that an answer, B?
1.57.
What's that?
1.57.
Yeah.
What unit? I forgot this. Well, you should know the unit. What unit?
Newton meter.
Tis not.
Water.
Yes.
Oh, no, not doing it.
Go for it, Andrew, what was it?
1.57 waters.
There you go. And then the next part, if the angle is 10 degrees, what do we multiply by? Cos 10, what does it do? Slightly less, because the angle is nearly 0. Yeah? Okay. Let's do the tutorial questions together. We'll take turns again. Can I continue? Yeah. Right. Just 3 questions, and they're all the same, straightforward. So, the first one looks like, is it a bill? Yes. Second one, DC motor. And third one, flux linkage, just like my 3 examples. So just do number 1, and when you're finished, tell me, and then I'll do it. Yeah. Part A or part B? Are you having trouble with the first one, Fran? Too much English or too much maths? The shape, no shape. You have a copper wire inside a magnet. So this is the build formula. Go back. Yes? No, it's not that one. Go back. Go back. Yeah, this one.
So which is the one?
Yeah, you finished it? Great. So what formula, Andrew, do we need for part A?
The
Bill, yeah. And what's, yeah, here, what's the B here?
4. No, B is 6.
Yep. The I,
4.
the L,
0.4 squared.
What's wrong with you?
0.4 squared.
No, 0.4.
What?
Sorry.
What? Well, what? What? Okay. What's the answer? Lee?
Yes.
What's the answer? No, Lee's turn now. He's getting distracted.
This one.
What is it?
Next one.
And what unit?
New.
Good. Okay. Omar, have you got the B part? What formula do you need?
same, just multiply 97 again.
Yeah. So what did you get then?
9.02. No.
Yeah. About 9. Yeah. Okay, very good. Easy.
Yeah.
Yep. Right. Now try number 2. Hi, son. Do you have something that prevents you from sitting quietly?
It's just me.
It's your personality. Your charming personality.
Only inside classes.
Oh, okay. And are you going to tell me only inside my class?
No.
Oh, good. Good. Would it be, for example, inside Lorraine's class?
Yeah.
Would it?
Yeah.
And she doesn't kill you?
She tells me, but I do I care.
Yeah, no, I get that.
Shake my hand.
Yeah.
What's the symbol that we use for talk?
The T, the
Tau.
Why clap your hands?
I turned it off because I knew you were going to do this.
What?
I told him the secret to my phone.
Clapping turns it off or on? Or both?
Clapping 3 times
Yes.
makes it start like ringing and flashing and vibrating.
Why would you want a feature like that?
Because I always lose my phone. Like, in the-
Ah, very good. Okay.
And it's extremely sensitive. Like,
Show me. I want to test this.
Is it an application or is it a setting?
What's the unit for
The
torque?
application.
Newton meter.
Use your phone?
It's an application.
Find my phone. What's it called?
That's very complicated.
Dude, where's my phone? No, let me.
Advertisements.
Wait,
Okay, it's working? Okay, so we'll pretend. Oh no, I can't find my phone. Wait, I know. Lame. This is a...
Oh wait, I turned it off. Wait, yeah. What's this?
So what do you do if you lose your phone and the battery dies?
Then you're...
Then you're screwed.
you're-
Right, let's try
you're gonna
again.
Go back to the old way.
Oh no! Without my phone, how will my friends contact me? Is that it?
Yeah.
That's...
No, I have some silence.
Oh, okay.
Put it
We
on.
want to
Put
put
it
it
on.
on.
There's no point.
I want to see how dramatic it is.
No silence.
I'm here.
Right,
Wait, let me test it first.
worst app ever. Right,
I have
continuing.
the settings.
Whatever, it's garbage app. Right, number 2. Have we got number 2?
Yeah, okay.
Go Steven, scene 3.
No, sorry, this movie is over. It's a disaster. Right, number 2. What formula do I need for number 2?
So much.
IBAN.
IBAN, yes. Okay, yeah, here's your chance to redeem yourself. Torque is IBAN. What is the I?
2.
2, the B.
6.
The A.
0.3 squared.
And the N?
2000.
2000. And what did you get?
2160.
Is he right?
Yep.
Good job. Finally, number 3 now. It's a new one, Faisal. I've heard you sing, I've heard you whistle, tap, make beat sounds, but not that one. That's kind of like the Crazy Frog sound. Yeah, it's kind of like that, yeah. It's good to see you're evolving.
We don't take the N as the number of turns.
No, we do. The number of slices.
But it's...
You see, if it's wrapped around 200 times but it's spiraling up, then each turn represents a slice, a circular region of space.
Yes, number of turns.
Lee, do you have number 3 now?
Yeah.
Go on. Omar? Okay, great. So, Fuan, what formula do you need for A?
Wait, it's different from bottom
Okay.
to top and top to
Can you go back for a second?
No difference.
Okay.
Okay, Fuan, what formula?
Then equal MBI
And what's N?
200
B?
3
A?
pi multiply 0.15
And the answer?
18.85
Say again?
18.85
Okay, and the unit?
WB
Which is called?
Spider.
WB?
Weber.
Weber. Okay. WB is fine.
Like Spider-Man, you said.
Yes.
Spider-Web.
You know spider web? Yes? Spider web? This is a square spider web for some
Look at
reason.
any window in Ireland, there is a spider-web.
Spider web.
You have so many spiders over here.
Yeah, they're friendly spiders.
Yeah, but
It was on the toilet
they're
floor.
not
Yes,
superhero spiders.
No.
In the bathroom on the toilet floor, there was one like just there, like.
Like you leave your bike
Do
for
not give
2
him some
hours.
privacy. Clearly it's using the toilet. Right. B. Okay, Fuang, what's different in B? Yeah. So what answer do you get?
17.
What was the anger?
17.7.
Oh, 20. And the unit? What?
Water.
Weber. Good. Good, good.
Are we going to be given these formulas?
I think you do have formulas in the formula book. He asked me, would you get the formulas in the formula book?
I'm checking it.
You had the formula book printed? Nice. Faisal's going to check for us. What are you doing on your phone anyways?
The new form. No, not this.
Whoa, no.
Sorry, I'm boring you. Did you find the formulas? Okay. Let's have a look here.
Yeah, we have the bill,
You have Bill, yeah?
we have bill sign,
Bill sign,
and we have the magnetic flux
NBA.
without the N.
Did
BA
you get it?
flux.
Okay, yeah. Do you have IBAN?
No,
No IBAN. Okay.
field is due to a long solenoid.
What's that formula?
Macro and mu
Yeah.
and N.
U and L.
B equals mu and N.
May I see? I do not know this formula you speak of. In the formula book, to answer your question, Yahya. Funny.
I don't know why they give us a different form of this. Or why you teach us a different form.
It's weird that this formula is in the formula book. Because I've never seen a question in the exam that requires this formula. So it seems like you have extra formulas. I better check that they didn't sneak it into the syllabus without telling me. Anyways, Yahya, you wanted to know, and it doesn't look like all the formulas are here. You have Bill, and you have BA cos theta. You don't have IBAN.
So we have to memorize that
Yeah. Yeah. I'll have to, let me just add that to my to-do list. Check out new formulas. Which year was this?
No, 15.
Right, we'll start the next lesson.
One.